Hello student, this video lecture is prepared for heat transfer subject for diploma student. I will discuss the unit number 6, that is evaporation. In last lecture I had discussed about multiple effect evaporation system and we had compared the forward feed and backward feed arrangement. In today's lecture we will discuss how to decide the optimum number of effect in a multiple evaporation system and vapor compression systems. That means vapors are compressed by means of a mechanical recompression and thermal recompression. So these points we will discuss in this lecture. So let us start the lecture. So this is the optimum number of effect in a multiple effect evaporation system. That means how to decide that optimum number of effect in a multiple effect evaporation system. That means in simple word we can say how many evaporators you can connect in a series for your given system. So that will be decided by this graph. So this graph on x-axis a number of effects are plotted and in y-axis cost is plotted. And there are different curves. So if we increase the number of effect between the steam supply and condenser, increase the amount of evaporation per kg of steam feed to the first effect, and also operating cost will be less. But at the same time, the capital cost and repair maintenance cost is increased with increasing number. So if we look at this graph or this line, so these are the fixed charges. So these fixed charges are increased. At the same time, cost of the steam and cost of water is decreased because the economy of the evaporator is increased. That means per kg steam feed to the next evaporator is decreased, but at the same time the labor cost will remain same for any number of effect. Then how to calculate the optimum number of effect? So you have to analyze these factors or these charges, and then you have to plot the total cost. That means you have to add the fixed charges plus operating charges plus capital cost, maintenance charges. All these charges you have to add, and then you have to plot the total cost. And when this total cost is become minimum, that point or that number of effect you can take as a optimum. Suppose here if we obtain the total cost minimum, then you have to go through this line on the x-axis, and here the numbers are written, that is 1, 2, 3, 4, and if it is there is a 3 number, then you have to use the 3 effect in multiple effect evaporation system. So in this way you can decide the optimum number of effect in a multiple effect evaporation system. So it is totally depend upon the cost analysis. The next one is the vapor recompression. So this is the another method by increasing the economy of the evaporator, and it is used for a single effect evaporator. So the thermal energy of vapor generated from a boiling solution can be utilized to vaporize more water if at all there is temperature drop for heat transfer in a desired direction. That means heat evolved by the evaporator, we can use that vapors as a heating media for a single effect evaporator. So here driving force, that means temperature drop, is created by increasing pressure That means we have to increase the pressure of that vapors, which increase the temperature drop. And this method is divided into two parts, that is mechanical recompression and thermal recompression. So here we will discuss first mechanical recompression. So in this method, so this is actually your evaporator. You have to feed the material as it is. Then you have to add the steam as it is. Then heating is taking place here. And when the vapor is removed from this evaporator, that will be not thrown into the atmosphere. You have to add that vapors into the compressor. So here in the compressor, the pressure of that vapors is increased and delta T, that means temperature difference, is increased. So this vapors is adding with some makeup steam. That means if this vapors is having some losses, so that should be equal by adding makeup steam, and then it is fed as a heating media to this heater. So these vapors is used as a heating media. Instead of feeding separate steam line, we can use these vapors as a heating media. And this cycle is repeated. That means thick liquor is produced, that will be taken out from here, and remaining part is recirculated. So in this way, the vapors are compressed. So it is called a mechanical recompression. So these are the compressors. So compressors are nothing but these are the machine which used to increase the pressure of vapor or gases. There may be positive displacement, means reciprocating compressor or centrifugal compressor. Then there is another method that is known as the thermal recompression. So method is same, but the equipment is different. So in this method, the vapor is compressed by means of a steam jet injector. And for that steam jet injector, we have to use the high pressure steam to compress the vapor which is coming from this evaporator. Okay. So this is your evaporator body. You have to feed the material from here. This is the heater. Then you have to circulate this feed into this evaporator body. So the evaporation is taking place here, and part of the vapors are removed to the or fed to the condenser, and part of this vapor is fed to this steam jet injector. So this steam jet injector, you have to add the steam, high pressure steam from here. So this steam is mixed with this vapor and the vacuum is created here. So these vapors are automatically coming here, and these vapors are compressed in this converging and diverging section. So you must be familiar with the fluid mechanics subject. So converging and diverging section are there. So these vapors are compressed, and again these vapors are fed to this heater as a heating media. So this is called a thermal compression. So instead of compressor, we are using steam jet injector for increasing the economy of that single effect evaporator. But the advantage of this thermal recompression is it is having low mechanical efficiency, means output divided by input, that efficiency, mechanical efficiency is low as compared to compressor, and lack of flexibility of the system to meet changed operating condition. Flexibility means we have very limited option to change the parameters. This is called a flexibility. So these are the two disadvantages of this system. Then we will discuss the problem. So before going into the details of the problem, you have to just recall these two equations. that I had already discussed with you. So you have to just remember this overall material balance, kg per hour of feed is equal to kg per hour of water evaporated plus kg per hour thick liquor, and this is the solute balance. Solute in feed is equal to solute in thick liquor. So these two you have to use for the calculation of how to calculate the water evaporated, and in calculation of steam economy you have to use this formula, that means heat balance along with the material balance, and also you have to use this formula and then this formula. So let us start the problem. So this is we will discuss first problem number 1, which is depend upon the material balance. So operating an evaporator operate at a atmospheric pressure. So this is the atmospheric pressure in kilopascal, 101.325. Is fed at the rate of 10,000 kg per hour of weak liquor containing 4% of caustic soda. That means this is the your solute which is having 4% by weight. Thick liquor leaving the evaporator contain 25% caustic soda. Find the capacity of the evaporator. Okay. So input we are having 4% caustic soda, and after concentration we get 25% caustic soda. That means here suppose you have to feed here 4% caustic soda, and after evaporation you have to take the 25% caustic soda from here. And what is the feed rate? 10,000 kg per hour. That means this feed. This is the feed. That feed is you have to add in this evaporator. So first we discuss write the material balance. So here the solute is the caustic soda, and obviously the solvent is the water. So remaining part is water. So in feed we are having 4% caustic soda, and in product we are having 25% caustic soda, and remaining is the water. Okay. So water means you have to just find out the what is the kg of water evaporated, that is known as the capacity of the evaporator. So just write the material balance. Caustic soda in feed is equal to caustic soda in thick liquor. Here we the 4% you have to divide it by 100, because it is given in percent. You have to convert it into the weight fraction, multiply by 10,000 is equal to 0.25 and multiply by m dot. So m dot is not given here. Okay, in that problem you have to calculate. So if we know these three quantities, we can calculate easily fourth quantity, that is m dot. So this is the kg per hour of thick liquor of 10. Then it is equal to 1600. Then you have to feed this in the overall material balance. So kg per hour of feed is equal to kg per hour of water evaporated plus kg per hour of thick liquor. So 10,000 we have already fed. This quantity we does not know, and you have to we have already calculated. We had already calculated kg of thick liquor. So 1600. So if we replace rearrangement this equation, we get 10,000 minus 1,600, 8,400 kg per hour. So this is actually kg per hour water evaporated, which is also called a capacity of the evaporator. So in this way we can solve this problem. So this problem is depend upon the material balance. So here I want to conclude this today's lecture. So today's lecture I had discussed about how to discuss or calculate optimum number of effect in multiple effect evaporation system. Then we had discussed vapor recompression, both methods, that is mechanical recompression and thermal recompression. And after that I had discussed one problem which is based on material balance and how to calculate the capacity, that means kg per hour of water evaporated in the evaporator. So remaining part we will discuss in the next lecture. Thank you.